All right, Sweta, let's move on to our next session. It's on the topic real-time cosmic chat presented by Divakar Kumar. Divakar is a senior software engineer at H&M, and he will show us a cool demo on how to build a cosmic chat application in real time using Azure Cosmos DB and Azure Functions, and also use the Azure Web Sub. That's one of my favorite topic as well. Let's hear from Divakar. Over to you.
Hello everyone, thank you for having me here. Welcome to my session. So today we are going to see how to build a real-time Cosmic Chat application using Azure Cosmos DB. So myself, Divakar Kumar, I work as a senior software engineer at H&M. So our entire session is going to be based on an application that I have developed known as Cosmos Spark. So it is not only the chat application, there are other Azure components integrated within this, and how the Cosmos DBs are interlinked within these components that we are going to see in the next few minutes. So the main objective of this session is going to be I had a lot of learnings while building this Cosmos Spark application. So I'm going to share those learnings with you as well. And I just want to make sure you understand the data flow between these different Azure components within this application, and some of the few examples when it comes to the design considerations. So when you want to choose the right partition key, and how you can make use of the change field in order to do that. And the third part is the most interesting part, because at the end of the day, we need to show something in the front end, right? So we are going to see about the web sockets and how it can be interlinked within the Azure Cosmos DB. And at the end, we are going to see a real demo on this one. So to start with, so we are going to see the change field. So this is going to be our real hero of this application. So if you are new to this Cosmos DB, change field is nothing but a list of persistent records that keeps on listening to a particular Azure Cosmos container. So whenever there is an update happening in your documents, it keeps on listening to that, and it lists a sort of, it sorts those documents in the order that they were modified. So by this, you will be guaranteed on the order that they are modified only within a particular partition key. So what I mean by that is, say suppose you are querying on different partition keys, or if you are having a different partition key which is not suitable for the order delivery. Consider this example, a retail industry, right? So you are adding an item A to a shopping cart, and adding an item B to a shopping cart, and then you are removing an item from the shopping cart A, and now you are checking out the items. So this should be in the order, because at the checkout, you don't need to have the item A in your checkout, right? So in order to do that, you need to define your partition key in a well way. So what I mean by the partition key is, it is just a key for your document to uniquely represents your document, so that you will be logically differentiating a particular set of records within your container. And internally, what happens is, these list of records to a particular partition key will be stored in different physical servers. So that makes it easier for you to query a particular document when you are pointing to that partition key. So make sure that you are choosing this partition key wise when it comes to the ordered delivery as well, because the change field works in a way with this partition key only, and you will be getting this in order only if you choose the right partition key. So as when I started working on this application, there were few questions that came up. So how to listen for create or delete events, because the capability of this change field is to listen for the any modifications with respect to the documentation, but it doesn't listen to any delete events that you are having within the documentation. So how to do this? So the one way of doing this is to soft update or soft delete. So by this way, you can have a flag internally within your document, say suppose is update or is create or is delete. So you can point it to either true or false, so that you will be knowing, or you will be able to differentiate between a create and an update operation. And as well, you will be able to make sure that this is going to be a delete operation, and you can perform your business use case further on. And if you are worried about the documents being stored even after the delete operation, because now we are following a different approach, having the soft key to make sure that change feeds are listening to these events. So you can use the time to live property, which will make that particular document to be expired after that specific period of time. So this is one way of going about the differentiating your operations. Either it is going to be a create or update, because this would be the common scenario which everyone might be ending up with. Because if you are already using the change feed, you might be knowing this, like you won't be able to differentiate between the create or update operation and as well the delete operation. So this would be the right way to go about it. And there are different common scenarios where you can think change feed would be a better fit. So consider there are different data that is going to flow into this Cosmos DB, which you have as your persistence layer, and your change feed is going to listen on to these data or modifications of the document. So once you are listening to these events, so one way of thinking about this is like you can trigger an API at the downstream. So you can either have your APIs in your Azure functions or your app service, or you can even trigger a notification through the Azure notifications apps. You can think of a scenario in that way, or you can even think of a real-time processing scenario where you are using these real data for the stream analytics purpose. Or else you can even think of it way of like having this solution, this use case for the migration scenarios as well. Like if in case like you want to replicate your data to a different storage, or if you want to have a same copy of data into a different container, you can think of change feed as a use case for your business use case as well. And as when I started architecting this solution, so I end up in this question. So can we have multiple listeners on the same Azure Cosmos container? Because this would be the common scenario in the real world. Because if you consider a single event, there might be multiple business use cases based on that. So in our application, consider there is going to be an user created event. So I can trigger a mail to that particular user, or else I can update the specific address or location of them in the Azure Maps that we are going to see in the demo. And also I'm going to push the notifications into the WebSockets. So these are different events that you can consider for a single event, right? So in these many cases, like you might end up in having multiple listeners on the same Cosmos container. So is this possible? Yes, this is possible. The way to do that is using the leases. So the leases is nothing but the concept of the documents which has the checkpoints for your Azure functions to work. So consider this is going to be your Cosmos DB change feeds, and there are going to be different Azure functions that are going to listen on to these change feeds triggers. Okay, so whenever a particular Azure functions is failing or shutdowning for some reasons, so the leases is going to contain a checkpoint which allows you to go back at the exact same place, like once it restarted the Azure container. So you can either create, you have two options to go about this. So you can either create one lease per container per functions, or you can have a shared leases container. So in the first case, there is a trade-off, like because now you need to incur additional costs, because the leases is also going to be a new container, and you need to provision throughput or for those containers as well. Or else you can have a single lease container that can be shared across multiple Azure functions, which can be handled for different use cases. So this is one way of going about this, and this is the best practice. But there is a trade-off that you can think of in future in this shared leases container as well. Because consider a scenario where you end up adding more and more subscribers to this particular change event. So you might reach this situation where you need to increase the throughput average consumption. That again also gonna consume you some amount, like where you need to reconsider on increasing the throughput for the particular container. So the other alternative for going about this is using the event grid solution. So the event grid solution is the publisher subscriber model. So there can be many event sources. It just publishes this event to this event grid, and there can be many subscribers that you can have as an event handlers. So the publisher doesn't know, it doesn't wants to know like what the subscriber is going to handle in the later stage of the time. So in our case, you can have one Azure functions that is going to be a Cosmos DB trigger for listening those change feeds, and you can publish these events to the event grid. So now what happens is you can add as many subscribers as you want in the future as well, and you are not going to incur any additional cost with respect to the container. So this is one way of going about this, and that is how I have modeled my application as well. And the next part is like the next question that I had is how to publish the real-time events to the front end. So whatever we have seen till now is good. Like whenever there is a change in the database, we are able to capture it in our backend system. But how to get it all the way out to the front end? So in our application, so our front end is based out of the plain JavaScript and HTML page. So how to go about this one? So the one way of going about this is using the WebSockets protocol. So now we need to think of a different protocol other than the HTTP, because if you are using HTTP protocol, you need to use a long polling mechanism where you will be pinging for an quite period of time to the server, like whether the data has been reached or whether the data has been changed. So only then like you will be receiving those real-time events in your application. But WebSocket is a different concept or different protocol on its own, where you will be opening two-way communication between your server and the client, which makes it easier for you to publish the real-time events, which gets delivered in a near real time to the front end. So one way of using this, using the Azure services is I have used the Azure Web PubSub service. So this allows you to handle this WebSocket connection between your client and the servers. So as it is shown in the diagram, so there can be number of clients to whom you can broadcast a message to, and from the clients also you can directly communicate with the Azure Web App Subservice without going through a round trip to a server, different servers. That is also possible. So we considered both of these scenarios in our application, which we will see in a bit. So the way to do that is using the sub protocol that you could see here. It is json.webpubsub.azure.v1. This is a sub protocol that you need to mention whenever you are initializing this WebSocket within your JavaScript. So if you have done this step, so now you will be able to interact with this web sub service directly from the client without having an intermediate server in the middle. So now comes to the architecture of our Cosmos Spark application. So this is going to be our device skyline. So consider this is going to be any browser or any user. So they are going to be reaching to our plain JavaScript HTML application that is hosted in the Azure Static Web App. So it is on a hosting platform where you can post the front end and as well the back end as well. And you will get a lot of other features which I'm not going to cover in the session because it is a different session on its own. So from this front-end application, we are going to call REST APIs. So we have defined REST APIs in the Azure functions as an HTTP trigger. So because our entire application is built out of a serverless mode, event-driven architecture. So that is where all of these HTTP calls goes into the Azure functions, and from the Azure functions we are persisting the data into the Azure Cosmos DB. So this is where the vital role takes place or kicks in. So now the different events will be fanned out to different subscribers. So from the Cosmos DB, the one way of listening to these events is using the Cosmos DB trigger, or the other way is using the change feed processing library. But the efficient or an easier way to use it is using the Azure function. Internally, this is also using the change feed processing library, which allows you to listen to those change feeds and publish those events to the downstream. So after it has reached to this Cosmos DB trigger, what I am doing is I'm publishing this event to our event grid topic, as we have seen earlier. The reason for doing this is so that like whenever in future, like if you want to add more subscribers to a particular event, you will be able to do that without incurring additional costs. And you can add multiple subscribers to a particular topic. So that is what it is depicted over here. And at the end, from the subscribers, you can either directly reach out to web subservice, which will publish or broadcast the message back to the front end. So that is how the real-time events are published to the front-end application, where they can see the chats are getting updated or the notifications are getting in the front-end. Or there is a way for the front-end applications to directly communicate with the PubSub service as well with our sub protocol that we have seen earlier. So there might be a case where you don't need to process the data, or you don't need to go through a set of intermediate servers, and you need to directly communicate with the PubSub service so that it directly reaches the other clients who are listening to these events. One thing to consider here is like whenever you type a message, like in your WhatsApp or in your Facebook, like you would have seen there is a little pop-up showing someone is typing a message, right? So in this, like you don't need to really store these messages in your Cosmos DB. You just need to publish these events to directly to the PubSub service, so that the other clients or the one who you are interacting with should know like you are typing. So for that scenario, you can directly communicate with the Azure Web Subservice. So now let's consider some of the design consideration that I have taken, like when I was building this the Cosmic Chat application. So one of the main thing I consider is replicating for the multiple partition keys. What I mean by that is, consider this is going to be one portion of our application that is going to be the chat application. Here you could see in the leftmost side, you can see list of chats that you have already communicated with. So these are list of people that you are already communicated with. So the one way of querying these or getting these list of documents would be going by the user ID, the current login user ID. So that would be the better partition key for this set of operation. And for the rightmost corner that you could see here is the list of messages for a particular chat item. So the one way of going about this is like you can consider having chat ID as your partition key. So there are different partition keys for different purposes here, but you are having only one business use case. Like you just need to type your message, and you need to consider both these scenarios in your real world. So one way of doing this is with the help of change field, because consider like there might be other scenarios as well, like an application can be a read heavy or write heavy application as well, or there might be a similar case where you might also end up like where you want to query on different parameters, and you want that to be in an efficient way. So you can make use of change feed in order to replicate these partition keys or replicate these documents into two different containers. So we can see that how it is done in this Cosmic Chat application. So Cosmic Chat is the container where all the messages are stored. So you can see I have chosen chat ID as a partition key for this container. So whenever they click on a particular chat item, so I'm going to use this chat ID as my querying filtering option, so that all the messages for that particular chat will be retrieved in a faster pace. And once I done this, like there is a change field listening to this container, which will duplicate this data to a different container with a minimal set of data. So I will be normalizing these data as well, which is required for me to show that left portion of the chat application, where I need to show to whom I sent message and what is the last message that I have sent, and also the icon of it. So those things I need to store it in a different container with a different partition key. So now the partition key that you could see here is the user ID. So whenever I retrieve the left portion of the screen, I use this user ID as the partition key, and whenever I retrieve the list of messages, it is going to be the chat ID. So this is one way of going about like how to replicate your multiple partition keys. So let's see a quickly demo on this one. So let me refresh it because I have opened this for a long time. So the PubSub service, I have made it available for 1 hour. So let me refresh this. So in the topmost portion, you could see this is going to be the Azure Maps that I have integrated with this application. So as when I logged in, you could see there are a list of markers getting updated. So this is based out of an Cosmos DB container, which is having a change feed, which is going to publish an event to the web subservice so that like it updates each of these markers. So as when a new user is going to join in, so that marker is going to instantly get updated in this particular page. So let's see, like this is going to be the chat application. And the one that you could see here is the list of tasks that are assigned to a particular user. So these are list of tasks, like once you complete a particular task, like sending hi Cosmos Park to a particular user, you will be awarded with 2 points and you will be able to see that the list of scores is getting updated in a real time. So these are different scenarios that I made use of the Cosmos DB in order to work with these different things. So if I chat someone, like if I chat with someone from the New Delhi, so I will be rewarded with a point, 2 points, and I will be a top scorer now. So that will be a different use case. So let me also log into a different account so to show you how the chat application works. Let me have it side by side. Okay. So now I'm gonna interact with a different user. So when I start typing, you could see there is a little pop-up showing here. Divaka Kumar has started typing. So this is something I have published directly from the client to a web app subservice. And whenever I post a message here, so that will go about like it will first reach us to the web app subservice so that like it shows you like Divaka Kumar is typing, and then like it will reach us the so there is a cold start because I am running in the Cosmos DB serverless mode. So you might expect a cold start for this one, and you will be able to see like the messages has been retrieving, and it will be shown in the in the other users type. So this is how the change feed works. So and the entire flow works. So I will get back to the slide. Maybe I will show you a slide on how this thing works. So this is the entire data flow that you can see in the entire application. I'm not going to confuse you with this entire flow. So consider, I'm just going to consider one of the scenarios that is going to be the leaderboard update. So there are different containers I have taken into consideration for this one. So one of the main thing is the cosmic chats where the list of messages gets added. So I'm the one of the events that I'm listening is the cosmic chats updated event. So I'm going to publish this event to the event grid subscriber. So it is going to update a new container where I'm going to store a normalized data of it, and I'm going to use that for a different logic. So there is a different container known as Cosmic User Task, which lists all the tasks for me for allocated timestamp. So this will subscribe to a different container, which will update the leaderboard score, and it will trigger a different change feed event, which will again call a different subscriber, which is going to be a leaderboard score update. So that is how the entire flow works. Like now the from this subscriber, it directly publishes the message to the PubSub service, and then it publishes the events to the front-end application. So this is how the entire flow works within this application. And I think that's all I had for sharing. Yeah.
Thanks, Divakar. I think that's an awesome scenario and the demo you covered. Even at Microsoft, we know that one of our favorite collaboration tools team is using Cosmos DB to enable so many features using change feed. I think it's one of the favorite topic among developers as well. Can you talk more about what are the deployment configurations of each resources that you spoke about, like Azure Static Web Apps, Azure Functions, Event Grid, and then PubSub. And have you estimated the total cost for this application? Because this looks like an interesting app. Probably other developers would be interested to build something like this. Yeah.
Exactly. So since this is going to be a demo application, so whatever I have considered is in the serverless mode. So right from the Azure function, it runs in the serverless mode, and as well the Cosmos DB that is going to run in the serverless mode. So there are different scenarios where you need to consider different modes as well with respect to the Cosmos DB. So in Cosmos DB, there are other modes like manual throughput and auto provisioning. So if you are gonna go ahead with the Cosmos DB as a serverless mode, there is a trade-off. Like you need to note down. So because now you will be having only single region capability, so you won't be having this global distribution or the feature that you have with other modes. Like you don't have that in the Cosmos DB serverless, but it just works fine for me since this is going to be a demo application. And the cost is much cheaper, but haven't uh, gone through or looked at it because I just completed this entire application just a few days back. So it might take for me time for me to consider those things as well. But I would say, like, since I have considered Event Grid as my intermediate PubSub pattern, so there is a cost reduction in that as well. So now I don't need to pay an extra cost for having different leases per function or having a shared leases. So there is an per million free connections that you will be getting for the Event Grid as well. So that is more than sufficient for this demo application. But in the real world, you need to consider other things as well when you are considering designing the application.
All right. I think you answered most of my questions. Sweta, do you have a question?
Yeah, so Dibakar, you've used functions at two places in the architecture, to write to Cosmos DB and also read. So just was curious to know what was the experience of that integration? What were some best practices that you learned?
Yeah. So one of the easiest way to listen to these change feed is using the Cosmos DB trigger, which uses this push model. So you don't need to pull the model, you don't need to have your own pace. Like there might be a scenario where you need to have your own pace of pulling these messages from the change feed. But this acts in a way like whenever there is an message or modification to a particular document, it acts as in a push model. So the Cosmos DB trigger kicks in. Or else you can design your own library out of this change with processing library, which would incur you an additional time. So if
Right.
you want to make already an existing usage of the Azure functions, you can go about with this Cosmos DB trigger, or else you can rely on the change feed processing library, because internally Azure function is also gonna use this CFP for the processing.
Makes sense. Thanks again, Divakar. This was a wonderful session, and every business does have its own website, so many of them may need to offer differentiated experience to their customer. And looks like a chat feature like this will be super helpful for other developers and app providers as well. Right, Saji?
I think I think you are spot on, Sweta. It's a real challenge to create something like this, like global scale real-time application, where you can collaborate with among others, right? So thank you, Divagar, for this amazing session with the cool demo that you
Thank you for
showed.
having
You have shown us how easily it is to solve this type of challenges using Cosmos DB and various components on Azure. Thanks again.